Hi class, this is course 3, lesson 26, transformations. A transformation is a change in the position or size of a figure. And then here's a little note that you're going to want to make sure that you know. After a transformation, the result is an image labeled with prime notation. Okay, and I will explain what that means here in just a minute. But, or you'll see it as in a couple examples. But if we have like a point A and then we transform it, we would then have that's prime notation right there, the little apostrophe or tick mark. So this would be the image, and then this is the transformation image labeled with the prime notation. So a translation, okay, so we have transformations, so we're going to change the position or the size of a figure. And there are 4 that we're going to talk about today. Translation is a transformation that moves each point of a figure the same distance and in the same direction. Okay, so all we're going to do is slide it. So informally, a translation, and you see this SL here and the SL here, you can think of a translation as a slide, but if the problem says what transformation was used, do not tell me it's a slide. Tell me it's a translation. Okay, so let's do a translation. We are going to translate this triangle, triangle ABC, 6, -2. Okay, now there are different ways to show this translation, but our book is going to use this notation, and what that means is we are going to have a horizontal shift and we are going to have a vertical shift. Okay, the horizontal shift corresponds to the X coordinate here, and the vertical shift corresponds to the Y coordinate. So this is telling you which way to go, left or right. Left or right. Ooh, touchy today. Left or maybe. There we go. Left or right. This guy is just really touchy today. Left or right, and the vertical is going to be up or down. Any guesses how you're going to know which way to go? If you're going to have to go up or down or left or right? Well, if it's positive it goes up, and if it's negative it goes down. If it's positive it goes to the right, and if over here, sorry, if it's positive it goes to the right, and if it's negative it'll go to the left. Okay, so positive, negative, positive, negative, just like your graphing points. Okay, so we need to translate this. We're going to move each of these points 6 units to the right and 2 units down. Okay, so we're going to go 6 over, so how many did I go there? 1, 2, 3, 4, 5, 6. Now do you see what I was doing? I was just counting across. Okay, from this point A at -5 to this point A prime at 1, that is 6 units to the right. Now I also have to go down 2 units, so I'm just going to move down 2 units. Now you can check this because we were at a vertical 2 and we need to go down 2, so we would be at 0. Now how do I label this transformation? A now becomes A prime, and B now becomes B prime, and C now becomes C prime. That's how I can tell that this is the original and this is the image. Okay, how about a reflection? A reflection is a transformation, again, that's what we're talking about. We're talking about transformations that flips a figure over a line called a line of reflection. Okay, and any line can be used as a line of reflection. When you think about reflections, you can think about mirrors. So we're going to make mirror images around that line of reflection. And informally, a reflection is a flip. Okay, so again, when you talk about when we talk about reflections or transformations and it is a reflection, don't tell me that it's a flip. Tell me it's a reflection. So let's do a reflection. We're going to reflect triangle ABC across the x-axis. Okay, now this might say over, or it might say about. All of those mean the same thing. Okay. So first you need to know what the x-axis is, right? So you have two options, and I hope that you know that this is the x-axis. And so now we need to flip this over the x-axis. What I do is I look at this and I say, okay, well, point B needs to be 1, 2, 3 above, and it's just going to go directly above. So it's 1, 2, 3. So that's point B prime. And A was 6 units below the x-axis, and now it needs to be 6 units above the x-axis. That is A prime. And C, same thing. We were 6 units below. We need to be 6 units above. That will be C prime. And then we would connect these points, and we end up with a mirror image. Now when you do these reflections on paper, if you fold your paper on the line of reflection, you should end up with overlapping figures. Okay. A rotation is a transformation that turns a figure about a point. Now rotation, you should know rotations, and that means that it turns. Okay. Rotations are going to be given to you in degrees, so it will tell you 90 degrees, 180 degrees, 360 degrees, whatever amount of degrees it is. But this is very important because it will seem backwards to you, and you need to know what we're talking about. Positive degrees, so an example would be 90 degrees. Those are going to be rotated counterclockwise. So which way is counterclockwise? Counterclockwise goes this way. Okay? Unless it specifies to rotate clockwise. So it might say rotate 90 degrees clockwise. If it says that, that's fine. Then this means you would go 90 degrees this way with the clock, or with counterclockwise would be against the movement of the clock. Okay, so we're going to do an example of rotation. We are going to rotate triangle ABC 90 degrees about point B. Okay, so what does that mean? So it means we're going to use point B as our pivot point, and we are going to spin or turn, rotate everything around that. Now how far is 90 degrees? Well, if you think about a full circle, if I start at point B, I would rotate like 90 degrees, right? I'm going to make a right angle, and I need to go counterclockwise, so I need to go in this direction. Okay, so if I start here at B, I need to flip these, rotate them, spin them. Sorry, I didn't mean to use the word flip. So that I have made a 90-degree angle. And these can be a little tricky. But do you see where C is right now? Point C. It is 1, 2, 3, 4 to the right of B. And if I wanted to make a 90-degree angle using this as a ray, BC, using segment BC as a ray, I would rotate up, and it would be in this area here, right? Okay. This line segment right there makes a 90-degree angle with segment BC. Okay, so this is the trajectory that C will be on, and it has to be 1, 2, 3, 4 away from B. So 1, 2, 3, 4 away from B is going to be point C prime. Now A from C is going to be 1, 2, 3, 4, 1, 2, 3, 4 in this direction here. That's A prime. And that one might be a little harder to see. But if you started here and went over there, you make a right angle from this point to that point. And then we would connect these and we would have B prime right there. Whoops. Because that would be the image. Now you might not need to put B prime because it is still point B. Okay, so we'll have to take a look at how our book is going to ask you to do that. Okay, so that's a rotation. Now, we have two different types on this page. Dilation is a transformation that makes a figure larger, and a contraction is a transformation that makes a figure smaller. And you know, when you get your eyes dilated, the pupils get really large. Or if you contract something, you make it smaller. Okay, so hopefully you can remember those. And these are similarity transformations. They change the size of the figure. Okay, so similarity transformations are going to make similar figures. Okay, so now I'm here. Similar figures, we've talked about them. This is a refresher that corresponding lengths are proportional. So we can make a ratio that is going to be our scale factor. So we take the image length, that's the one with the prime symbols, right, like A prime, and we're going to divide that by our original length, and that'll give us our scale factor. And a dilation is going to be greater than 1 because we are going to make it, you know, twice as big, or 1.5 times as big, or 5 times as big. But a contraction is going to be greater than 0 but less than 1. So we're going to have a fractional component there, or a decimal. So let's see if we can figure this out. A couple of other notes here. Perimeter is scaled according to the scale factor, and area is scaled according to scale factor times scale factor. And we've already talked about this. So hopefully you can see the connection between this lesson and a previous lesson. Notice that this is our original, and we have a dilation here because our image is larger. So we should have it in our mind that our scale factor is going to be greater than 1. So you can take any of the corresponding sides from the image. I'll take the 12 feet side, and I can put 12 feet, and then the corresponding side would be 6 feet, and when I simplify that, I get 2. So my scale factor is simply 2. Now if we go back to these two figures, if I calculated perimeter would equal 6 plus 2, 12, times 2, 12. That's not 12. This is 8 times 2, which would be 16. I got that times 2 in my head, and I went ahead and multiplied 6 times 2 instead of just adding them. So add 6 plus 2, 8, and then multiply times 2. That's 16, and remember that those units are just units, feet. If I calculate perimeter on the image, on the dilated image, I would get 12 plus 4 is 16 times 2, which is 32 feet. Notice that the perimeter of the image, 32 feet, is twice as big as the original. So perimeter of the image is what multiple of the rectangle ABCD? Well, it would be twice as big. And we knew that because perimeter is scaled according to the scale factor. It is just the scale factor. The area, however, if we calculate the area of ABCD, we have 6 times 2, 12 feet squared. And the area of the image would be 12 times 4, which is 48 feet squared. So now compare these two. How many times larger is 48 than 12? Well, you would multiply 12 times 4. So the area of the image is what multiple of rectangle ABCD? It would be 4. Now look up here. Area is scaled according to, it's the scale factor times the scale factor, which is, in fact, 4. Okay? I know you probably had a lot of questions today. Please use the notes feedback form or the question form on the website. That way I can have those comments or questions before class and can address them accordingly. Otherwise, I'll see you in class.